Hi, my name is Peter Donahue. I am a contracting officer in the Contracts Management Office at DARPA, and I'm very excited to be supporting Dr. Molly John on her new Cornucopia program. Today, I want to share with you some details about the award negotiation and execution process and give you some points to think about as you're considering preparing your submission for Cornucopia. As the CEO for the Cornucopia program, my role is to support Dr. John in getting the solicitation, the Broad Agency Announcement, or BAA, out on the street, which it is now, and importantly support Dr. John through the proposal evaluation and selection process, or what we call the scientific review process. Doing business with DARPA specifically for this program starts with your abstract submission and then proposal submission. It's the content and the quality of those submissions that will determine whether or not Dr. John wants to do business with your organization. With that in mind, I want to drive home a few points about the agency's scientific review process and provide some additional details on the acquisition process to help set you up for success and give you the best chance at being selected for the Cornucopia program. The easiest way to ensure you give your organization its best chance at being selected is to read the solicitation, the BAA, in its entirety, follow the proposal instructions in the BAA and the instructions in all the attachments to the BAA, and provide all the supporting documentation we request and require in your proposal. Now, by the time you're seeing me on your screen today, I've likely posted the BAA, so I assume everyone has had a chance to memorize it by now. We've given you adequate time to submit abstracts, and then we've given you well into the new year to submit your full proposals. So with that amount of time, DARPA's expectation is that we get outstanding, complete, conforming proposals. But let me tell you why it's important to read the BAA, follow the proposal instructions, and submit the required supporting documentation. There are 3 critical reasons, and if you've ever heard me brief at a Proposers Day before, these reasons won't surprise you. The first is you want to ensure you submit a conforming proposal submission. As discussed in the BAA, a non-conforming proposal is one that does not respond to all 3 focus areas, or does not follow the content and format instructions in the BAA, or does not provide all the required proposal information, or simply does not fit into the specific cornucopia research focus areas that we discuss in the BAA. And Dr. John will speak about these today. And we clearly state in our solicitation that non-conforming proposals may not be reviewed. As someone who is part of the process of assessing if proposals are conforming or non-conforming, this should be an easy first step to accomplish on the path to getting selected. Second, conforming submissions will be evaluated by a scientific review panel made up of government reviewers, all of whom have expertise and background and experience in this specific research area that Cornucopia is focused on. When the government reviewers evaluate your proposal, they're going to document strengths and weaknesses of your proposal relative to the 3 evaluation criteria listed on this slide. And based on those identified strengths and weaknesses, they will make a determination of whether or not your proposal is selectable or not selectable. At that point, the PM will decide if they want to recommend the selectable proposal for funding to the scientific review official, who is the DSO Office Director, Dr. Phil Root. So your goal is to help these reviewers identify as many strengths as possible when they are documenting their findings and convince them to invest in your organization. If your organization followed the solicitation instructions and provided a complete proposal package and all of the required supporting documentation that DSO requested, you're giving the scientific review panel members what they need to understand your research story, and all of the pieces to the puzzle are there for the compelling argument on why they should fund this project. Conversely, when there are holes in the proposal and missing documentation, and you haven't addressed the questions in the BAA that we want answered, the story is incomplete, there are pieces to the puzzle that are missing, and the reviewers start identifying weaknesses in their evaluation, and it becomes less likely that they will find your proposal selectable and recommend it for funding. The Cornucopia BAA is very detailed, and Dr. John has very clearly articulated the specific information that she needs to see in your proposal to understand your story. The third reason relates to your proposed costs and how we evaluate proposed costs under BAAs under the evaluation criteria cost realism. Under a BAA solicitation like this Cornucopia BAA, proposals are not evaluated against each other because they are not submitted against a common statement of work. The spirit of using a BAA is to solicit for innovative, revolutionary research ideas, which is Dr. John's goal under this BAA. And she has laid out her clear vision, goals, program objectives, and metrics for the program. But Dr. John and DSO are not prescribing any specific technical solution for Cornucopia. And because there is no defined technical requirements, price is not an evaluation factor, and thus there can be no adequate price competition under our BAAs. During the scientific review process, government reviewers only evaluate the cost realism of the proposal. What does that mean? For example, the government reviewers will analyze the proposed labor categories and labor hours for the prime contractor and all of the subcontractors. They will assess if that labor mix and level of effort are realistic for the research effort proposed. That's cost realism. They will evaluate if the proposed materials, equipment, and travel make sense for the proposed project. However, they will not evaluate if the labor rates or indirect rates, fee or profit factor, or prices for the materials and equipment are reasonable. That reasonableness determination is the contracting officer's job. It is a required step, and that happens only after a proposal has been selected. Which gets me to that third and final reason why it's important to read the BAA, follow the proposal instructions, and provide the required supporting documentation. If your organization is selected for award and you've received that correspondence that a contracting officer will contact you shortly to begin negotiations, it's at that point the proposal makes its way to the contracting officer's desk. The CO then begins analyzing every aspect of your proposal, assessing the reasonableness of every cost you propose, using all the supporting documentation you provided to support your direct and indirect costs, and other available information, so that the CO can develop a fair and reasonable government estimate for the research effort and make an offer to your organization. Our goal is that the entire process of analyzing costs, drafting award documents, finalizing negotiations, and executing an award takes 90 days from the date the CO gets the proposal, which is about 2 weeks after you've received your selection notification. However, often there is missing documentation in the cost proposal, missing quotes for materials or equipment, no support for the proposed labor rates or indirect rates, no detailed subcontracting proposals. And that's when the process starts to drag out beyond 90 days to 120 days and beyond. But if your organization submits a complete proposal package and the CO has everything they need to complete their cost analysis, the CO can get through their process faster, commence negotiations with you quicker, and execute an award in a shortened award timeline. And nothing would make the DARPA PM and your organization happier than to get started on the research as quickly as possible. So, most important thing to remember from my talk this morning is the importance of reading the solicitation, the BAA, following the proposal instructions, and providing all of the required documentation, because it directly benefits your organization to do so. You'll submit a conforming proposal that will be evaluated. You're giving the scientific review panel a complete proposal package with a clear story, helping them identify as many strengths as possible. And if you're selected for award, the contracting officer will be able to make an award to your organization faster. As a contracting officer, your cost proposal is very important to my team in helping us complete that required reasonableness assessment. It is required that proposers, both prime contractors and all subcontractors, use the DARPA-provided Excel cost proposal spreadsheet, complete it, and send it back with your proposal package. The spreadsheet is easy to use and ensures your team is providing the detailed cost information that the government CO needs to complete their analysis. The tabs in the spreadsheet are set up to ensure you propose detailed costs by phase, focus area within each phase, and by your contractor fiscal year. The spreadsheet requires that proposers complete certain information in the tabs that help DARPA in analyzing cost information. There are also instructions in the spreadsheet to guide your team. Most importantly, because the government team is familiar with the spreadsheet, we are able to complete our analysis quicker and commence negotiations with your organization faster, hopefully shortening that time to award period. As you can see, I have a common message this morning: fast award execution. Lastly, as stated in the Cornucopia BAA, all responsible sources capable of satisfying the government's needs may submit a proposal that shall be considered by DARPA. However, there are a few exceptions that are clearly addressed in the BAA. Specifically, if you are a federally funded research and development center, FFRDC, or government entity, such as a government agency or lab, you are subject to applicable direct competition limitations and cannot propose to this BAA in any capacity unless you meet the conditions in the BAA and summarized on this slide. This is a requirement that must be met. So, for example, If you are a government agency that does not have the authority to compete under a BAA, but want to support DARPA and participate in the program, great. Don't submit a proposal. Instead, you should reach out to the DARPA program manager using the BAA email address and express your interest in supporting the program and begin that conversation. If you are an organization that wants to submit a proposal with a government entity as a team member to support your program in some way, it's possible that government entity cannot be a typical subcontractor to your organization because they cannot meet the eligibility requirements in the BAA. There is a possibility that you may be able to propose a government entity to provide some form of government-furnished support. In that instance, DARPA may choose to fund the government entity directly to provide specific support to a selected research project. But organizations should ensure to propose it as government-furnished support in your proposal with an estimate on what the government-furnished cost might be. However, do not propose the government entity as a subcontractor or team member with those costs included directly in your cost proposal spreadsheet. If you have any questions about the information I presented this morning, please submit them to cornucopia@darpa.mil, and we will respond and post the answers to darpa.mil. Thank you for your time, and I look forward to receiving outstanding proposals and working with you soon.
Hello, and thank you for this opportunity to greet you on behalf of the Defense Sciences Office here at the Cornucopia Proposers Day. I wish we could be in person. Such is not the case. Regardless, thanks again for your interest. I'm here to give you a brief overview of DARPA in case you've never worked with us, but then dive a bit deeper into the office that I'm fortunate to work with, the Defense Sciences Office, that is hosting and investing in this area where Cornucopia exists. Cornucopia and many DARPA programs represent the propagation of many long arcs of investment. DARPA invests in individual opportunities, but when we look backwards, some of these appear to be a long arc of investment. On the bottom, you see enabling technologies where DARPA has been for a very long time. And hinting forward, the Defense Sciences Office has been a part of the formation of material science for a very long time. We've played a role in information technology, but what drives us forward is not just the enabling technologies, but the military capability that science and technology could unlock. See, some of those here, and what we ask here in Cornucopia is what's next. These long arcs of investment are made possible through individual programs brought together with what I believe is a unique culture. So I want to dwell on that for a moment. Three aspects of this culture that is different from other agencies that makes us different and unique. The first are our people, the government people that we have here, the program managers. Molly, for example, I believe is an exceptional technologist, but here for a very short period of time. So it drives us to move as quickly as we can. But we don't have any in-house capability. All of our work is done extramurally, and so that requires us to form programs and then seek to partner as quickly as possible and get this work started. To do that in a way that we believe provides the greatest opportunities for breakthrough development, we focus on specific end states and associate metrics with those program end states. That allows everyone in the program to be focused on what we believe success looks like and what would solve the problems at hand. And in this way, we believe we foster this culture that drives for off-scale impact given the limited tenure of our program managers, but we imbue them with, or they come with, this very risk-tolerant perspective to say, if now is the time, then we cannot ignore this opportunity, and we need to do so for national security. Not all of our programs are a success. Some of them fail to meet metrics, but we learn along the way, and we're tolerant of that in a way that we think is essential for national security. There are 6 offices within DARPA that all have the same culture, but different aspects of the overall mission. You notice that all of these are alphabetical. I moved the Defense Sciences Office to the left to break that alphabetical ranking or sorting and rather make it chronological, because I believe it's important for you to see the Defense Sciences Office as the far forward scouts along the scientific frontier. And so we look for opportunities across the areas of physics and chemistry, social science, artificial intelligence, optics, etc., that we can, where we can invest, reduce the technical risk, and then hand off to other service labs or potentially some of the other offices within DARPA. And in that way, catalyze progress for national security. So the mission for the Defense Sciences Office is to serve as DARPA's DARPA, meaning that we make the early investments, the high-risk investments, that then reduce the risk for then additional investments for national security. We are across this very broad scientific frontier, as I've mentioned, and what differentiates us, we believe, is a very strict focus on mission-informed research. This is where we believe our program managers can help you, not just on Cornucopia, but other ideas where you might have. You might be able to come to us and say, there's something I can do today that I couldn't do yesterday. And we can provide a perspective of what that could mean when viewed through a mission-informed lens. So please consider, and this will be my first of several please consider reaching out to us, not just on Cornucopia, but broadly when you think there's something that we can do today that we couldn't do yesterday and that we can't ignore in the name of national security. But I want to give you some idea of what we mean by mission-informed research. As we look for our priority areas, our mission-informed priority areas, I list those on the top, and I'll go through them very briefly. I'll start with better decisions faster. Picture it as a hypersonic vehicle. Don't mean to focus on just kinetics or just hypersonics by any means, but the ability to sense quickly, to decide quickly, and then to act quickly is absolutely essential. And so for us to do so requires us to focus in this mission area, and I'll translate that to our scientific thrusts at the bottom here in a moment. We also see mission areas that we refer to as undergoverned spaces. These are areas where, for example, a local population cannot exert sufficient influence to prevent foreign entities from providing undesirable influence. And so we look to help in these areas, but these are complex areas marked not just by technology, but also by social science and the complexities of the interactions between economics, for example, information, influence, as well as social media, for example. Resilient systems refers to the fact that much of our infrastructure benefits from improved resilience, but also we seek opportunities for increased early warning to make our overall national security apparatus more resilient. And then finally, coming back to disruptive innovation, we look for opportunities to take the science that we develop and make that, translate that into innovation as rapidly as possible. Doing so requires that we team with a broad ecosystem, not only within the Department of Defense and the services, but in many cases industry, to make the improbable possible and then make that possibility available to as many as possible. So we then translate those priority areas, those mission areas, into thrust areas. I've outlined the 4 thrust areas that we have in science and technology within the Defense Sciences Office here in this chart. And you see that there's a mapping from our investment areas to our mission areas. The limits of sensing and sensors, we look for new approaches in metrology and sensing that occur at a variety of scales and challenge some of our assumptions of what physics allows. Complex social systems is not just social science, but rather new techniques in science associated with human-machine teaming, as well as complex wargaming, meaning what are ways that we can build intuition in complex environments. I'll talk about anticipating surprise more, but this is a bin of investments where we seek to create surprise by anticipating where we need to be, where these investments need to be. And then we've had a long arc within the Defense Sciences Office associated with the frontiers of math, computation, and design, where we have some current investments in quantum information, but also some foundational investments in the science of artificial intelligence, and then also a long arc in design tools that allow designers in complex systems or designers in material systems to make new investments in science that allows us to unlock new potential. But I wanted to dive more deeply in what we mean by anticipating surprise, because I believe the Cornucopia program fits best within this bin. When we consider anticipating surprise, we want to ensure that our warfighters have access to the most advanced technology, so our warfighters never face a fair fight. So we look for these leap-ahead capabilities, but we can't leap ahead in all domains, and so we look to leap ahead in specific domains. And one area where we believe there are threats to which we need to respond is the area of logistics. And so when you see Cornucopia, you see an opportunity for us to break logistics chains and long logistics tails to allow U.S. warfighters to not only survive but thrive in areas without guaranteed access to logistical supplies. But we also see more broadly opportunities to help in disaster relief. And even more broadly, we see opportunities for Cornucopia to provide resilience to even domestic supply chains in the face of unanticipated surprises. And so the topics of interest you see here represent some of our investment areas that we believe could create technical surprise. And I would add to this the engineered biology that we think is essential within the Cornucopia program. But Cornucopia I don't want to bin into just engineering biology. Rather, we think the time is now to look for opportunities to start the work now in what would be a disruptive innovation. So rather than consider that a future day might be possible for engineered biology to deliver this, let's get busy today. Let's get busy now, building an integrated system that could deliver the results necessary to address this problem and then hence make significant impact for national security. So with that, if ever you think that today is a day that we have new capability that we cannot ignore for national security, I hope that fits within Cornucopia, but even more broadly, I hope you approach us, the Defense Sciences Office, seek new opportunities for breakthrough capability for national security. I thank you for your interest. Thanks for being here. And with that, I'll turn it back to you and to learn more about the Cornucopia program. Thank you.
Good morning. I'm Molly John. I'm the Cornucopia Program Manager from the Defense Sciences Office, and it's my pleasure to add my warm welcome to all of you who are in attendance. In this presentation, I will review important details found in the Cornucopia Broad Area Announcement. I will introduce our government team partners and will answer a few questions which will also be memorialized for all prospective performers as frequently asked questions. In between then and now, I will also have a chance to meet with some of you in sidebar conversations, which were assigned on a first-come, first-served basis, and you will have a chance to listen to each other, enlightening talks from prospective performers, and also to participate in teaming opportunities in the software called WonderMe. Please reach broad and wide to assemble your teams, availing yourselves of the opportunities we are providing, as well as your own networks, and use our program mailbox cornucopia at darpa.mil for any correspondence. When I'm finished with this presentation, you'll have the opportunity to hear from each of our government team partners who will describe their interests in these topics, as well as the capabilities, roles, and responsibilities they will bring to our collective efforts. This slide outlines the content of this talk. I'll start with the motivation and goal of the program, problem scope and challenge, share the vision for the program structure, give you an overview of focus areas, metrics, and deliverables, summarize a program timeline, and review key important upcoming dates. All of this information, or at least all of it that matters, is summarized in the broad area announcement, and I refer you to the BAA text for any specific questions or details that I either don't cover or that you'd like further information regarding. The Cornucopia program is named for the mythical Horn of Plenty. The vision for this program is both forward-looking and as ancient as the Greek myth. What if we could have a source of food that did not depend on seasons or soil or rain or oceans or financial transactions or fragile, highly consolidated supply chains optimized for efficiency at the expense of resilience? What if we had the capacity to produce nutritious food at the point of consumption? My office, the Defense Sciences Office, is soliciting innovative research proposals to develop capabilities for field deployable, on-demand production of a range of nutritious, palatable foodstuffs from engineered microbes, air, water, and electricity. Proposed research will investigate innovative approaches and drive revolutionary advances in the science, in devices, materials, and/or the systems themselves to enable production of nutrition on demand at the point of consumption within parameters associated with 2 DARPA-defined use cases. This slide summarizes our motivation in developing this program with key points bulleted. The 2 use cases we have selected with significant input from the services, our service liaisons at DARPA, and much more broadly through conversations within the DoD community, the larger science and technical community, are as follows. The first use case is modeled with a 14-person forward operating unit of individuals in peak condition, peak physical condition, who are male because of the more intensive requirements for nutrition. And this is modeled for sustenance for 45 days. So 14 men for 45 days in a forward operating environment considered austere. The second use case is modeled by 100 civilians, mixed ages, both sexes, that are maintained at a lower level of ration, at a restricted ration, or essentially survival rations, but more people, 100 people, for a shorter period of time, 21 days. This slide further develops the program's scope and lays out the Cornucopia challenge. On the left, you see the first use case summarized. To supply a unit of this size for 6 months requires nearly 7 tons of meals ready to eat, or MREs. MREs are shelf-stable, one-size-fits-all solutions that can be pre-positioned. But in view of their bulk, soldiers are often ordered to field strip MREs in order to save on weight in terms of transport to the field. In this use case, our goal is using a Humvee-mounted unit that with a payload of 4,400 pounds to mock up the capability to produce 50,400 calories per day, nutritional calories or kcals per day, at the operational rations level, or the nutritional standard for operational ration, NSOR, level, in less than 5 liters of water, such that 14 warfighters could be maintained for 45 days in peak condition. The mounted payload must include all devices, all elements needed for the process except the generator, fuel, and water. The goal in this use case is one nutritionally complete food format, most likely to be a shake. On the right, you see the second use case mocked up. In this instance, again modeling a humanitarian assistance and disaster relief mission, The idea is to produce 150,000 calories per day, kcals per day. This is sufficient to sustain 100 civilians at the restricted ration standard of 1,500 calories per day per person for a total of 21 days. And in this instance, it must fit into 4 quad-con containers, including all equipment, excluding fuel and water. And the goal is 1 nutritionally complete food format and 2 additional formats among the following. It could be gel or pudding, jerky or bar, that is supplementary. In other words, it does not have to be nutritionally complete. While there is a burgeoning commercial interest in food from microbes, and by microbes we specifically mean any member of the 2 different major kingdoms of bacteria, microalgae, fungi, protozoa, it is unlikely that the commercial sector, without investment, will meet the Department of Defense needs for a deployable system that produces nutritionally complete products. So to date, and we hope that many of you are in the audience today, companies are out there that are leveraging these technologies and approaches to produce a wide variety of foodstuffs, but there's been a strong emphasis on protein-based products, meat and dairy alternatives, for example. In general, those products mimic a particular foodstuff that is packaged and then put into the regular wholesale retail food supply chain. And the processing of that microbial output occurs separate from its production. And to date, there is not a concerted effort to introduce into the microbes in question the capacity to produce desirable flavors. So this program incentivizes that research. This program focuses on the opportunities that involve mobilizing advances in chemistry as well as in biology, and the integration of those is not necessarily incentivized by the market. Hardware for commercial production virtually always occurs in a plant-type setting, in a manufacturing setting. So there is no commercial motivation in place to date to produce a mobile or deployable unit. And finally, while these products are gaining widespread acceptance, some are well along or through the FDA regulation process, food is not generally consumed where it is produced. It is produced, packaged, and then sent out into the distribution system. So Cornucopia aspires to leverage the successes in industry to date and from academia and bring those toward the range of military applications bracketed by the 2 use cases we've selected for the program. This slide summarizes the program vision in a very generic sense. The idea is starting with very minimal inputs, electricity, water, air, that we use electrochemistry to split water, create hydrogen, maybe other small molecules, 1 or 2 or 3 carbon molecules, that may serve as fodder for microbes that convert those sources of energy to protein, indeed, but also carbohydrates, lipids, and dietary fiber. These cultures would then be grown to produce as close to an ideal composition with regard to human consumption as possible, as well as instilling in those cultures the capacity to produce desirable flavors. Those cultures are then harvested in a continuous manner and processed to create foodstuffs, initially a shake-type format, but also perhaps food formats in different textures. To illustrate the importance of the integration in this program, I've selected just one of the elements illustrated in this diagram to show how attributes, in this case microbes, how attributes of the microbes have to be taken into account in each of the three processes I cartoon above. So obviously, and I should say, I find a very useful analogy here to the same sorts of innovations that featured when humans domesticated plants and animals for consumption. So production-related traits, growth rate, versatile energy sources, robust tolerance to diverse environmental conditions, etc. Those sorts of traits are obviously really important to make the system work, but they have to be coupled with traits that make the microbes suitable food, that is suitable nutritionally as well as tasty. And all of that has to occur in a system that works within the size, weight, and power envelopes imposed by each of the use cases. So the program really emphasizes the assembly of multifunctional integrated teams and integration within and across the different areas of emphasis in the program. This is shown in more detail on the following slide. On this slide, I lay out the program structure. Cornucopia will be a 48-month program comprised of 3 sequential phases, 18 months, 12 months, and 18 months, respectively. There are 3 focus areas that comprise the overall scientific and technical thrust of the program. These focus areas, as I mentioned previously, are intended to be deeply integrated and will run concurrently through all 3 phases of the program. The first focus area really concentrates on the domestication of microbes to enhance their suitability as human food. Of course, human beings have been eating microbes as long as there have been human beings. We consume trillions and trillions of these cells. We are kilograms of them. And they feature very prominently in many important food processing processes such as fermentation. But in this instance, the idea is that we are directly consuming microbial biomass, maybe processed into foodstuffs, formats, flavors that make them more suitable. But ultimately, we are domesticating microbes for direct consumption. The second focus area emphasizes the ability to produce desirable flavors in these microbes, and also the characteristic of tailorability of the overall system. Tailorability signals the intent that this system will be able to produce on demand different formats, different flavors of food in one location. And finally, the third focus area is the focus area where we put the whole system together within the requirements imposed by the 2 military use cases. Program metrics and the phase gates, that is the tests that allow a performer to go from one phase to the next, are specifically derived from the 2 use cases. Performer teams must address both use cases through all 3 focus areas and all 3 phases. This is again meant to really push the ability to tailor output and to prevent the temptation to exquisitely tune a particular system to one very narrow set of requirements. Successful proposals will present integrated teams that address all 3 of these focus areas, both use cases, through all 3 program phases. Successful proposals will also explicitly and systematically consider technical risks in the plans and approaches presented and address mitigation of those risks. So at this point, I'm going to pivot and go into more detail in each of the focus areas and then review both the program metrics and schedule. Focus area 1, as mentioned, concentrates on considering the kingdom shown down in the lower right. This is just the bacterial kingdom of microbes that are potentially suitable as zones of prospecting for organisms that may be suitable for human consumption. The goal here initially is to show we can not only produce, but harvest all 4 human dietary macronutrients from microbes, air, water, and electricity with minimal to no supplementation. As work in this focus area progresses through the phases with opportunities for down selection of teams at the end of each phase, we intend to promote the development of the ability to control both the composition of the output with regard to macronutrients, so better tailor the output of the program to match human needs, and to address the micronutrient content in the output as well. Again, we are focusing on at least one nutritionally complete food format, along with the possibility of expanding both flavors and formats in other parts of the program. So successful proposals will describe the strategy, a technical approach, to simultaneously produce protein, carbohydrates, fats, and dietary fiber suitable for human sustenance from the starting materials. Nutrients can be synthesized by microbes, but it may be attractive to consider the possibility of synthesizing nutrients for direct consumption if necessary via chemistry. We will be looking for proposals that specifically address rate-limiting steps that definitively take steps to exclude known foodborne pathogens and contamination, and any microbial origin anti-nutritional compounds. And we will be looking for approaches that can feasibly fit within the envelope prescribed by the 2 program use cases. In this case, we have staged the progress from demonstration of just any approach to developing to producing these 4 macronutrients simultaneously, to a lower bar requirement, that is the restricted rations level, to a higher bar requirement, which is the operational rations level. So this slide shows the formal standards, which are administered by one of our government team partners, the Natick Soldier Sustainment or Systems Center, and described in Army Regulation 40-25. Natick has the responsibility of administering the regulation for all branches. So this is a table taken directly out of the Army's circular that shows the specific requirements for nutrients, including micronutrients, for the 2 different standards, the NSRR restricted rations and the NSOR operational rations. Focus area 2 is where the center of the work aimed at building in the characteristic of tailorability will center. So in this case, the goals are to develop the capacity to flavor via expression in microbes of molecules that are known to confer specific flavor properties. and to build out what we're calling the flavor catalog of this system. In the lower right of this graph, I show the chemosensory signature of an apple. This is a relatively complex signature. In other instances, the molecule or molecules required to impart a specific desirable flavor may be much simpler than this. So the goal in this is to explore the universe of flavor, select candidate approaches or candidate molecules that are compatible with this approach and that can be feasibly expressed in microbes, to bring those into the system and explore the suitability, and ultimately to achieve the ability to demonstrate via chemical analysis, test readiness to meet or exceed the rating of like slightly on the hedonic scale that is typically administered by the Natick Soldier Systems Center. We do not envision human subjects research conducted by performers. We are emphasizing in this program chemical analysis, not human subjects testing. Ultimately, the responsibility for evaluating the palatability of these products will reside with government team members according to prescribed protocols that are essential for any progress through the regulatory cycle. So, elements of a successful proposal with regard to Focus Area 2 will describe strategies to demonstrate the presence of and insufficient levels of molecules and presence of those molecules in sufficient levels that are known to impart desirable flavors in the microbial output. Successful proposals will describe the chemical analyses that will be employed to confirm the presence of those molecules and the way the presence of those molecules will be correlated to the attributes of flavor. And successful proposals will describe strategies to demonstrate the ability to shift production from food format to food format and from flavor to flavor. So the overall goal here is not only to generate nutritious food, but to enable the creation of tasty food. That is, expression of desirable flavors in microbial cultures and the subsequent processing. The third focus area is the area where we envision and begin to assemble and test and scope the actual system itself. So in this case, again, through an ordered set of requirements, we will focus on performers first defining and then setting up on a lab benchtop all the processes that performer team believes are essential to achieve this goal, Cornucopia's goal. Through each phase, the integration of those processes and the bringing of them within the size, weight, and power envelope, as well as the food safety and toxicity requirements imposed by the use cases, are enforced by the metrics. So successful proposals will lay out a clearly planned approach to achieve all the program metrics, including the incremental steps, and plans for a final demonstration of an integrated lab benchtop system that meets all Phase 3 requirements for each use case. So all three FAs, both use cases. In this case, the deliverable here will be output from a benchtop system. We're not expecting prototypes to be constructed, but we are expecting the demonstration on paper that the systems envisioned will fall within the program requirements. We encourage performers starting even with the development of the proposal, to plan for early dialogue with regulators. A number of companies in this space are already well along in their dialogue with the Food and Drug Administration with regard to achieving generally regarded as safe status. Again, we are not expecting that performers will take their products to or through regulation, but an open dialogue with regulators throughout, as well as with government team partners, will be essential. Another word about government team partners. We are delighted at the opportunity immediately following this talk for you to hear from each of our 3 government team partners. Each of them has been selected to bring unique and important subject matter expertise, as well as in-house laboratory capacities, and also offer very specific and important opportunities for Cornucopia, for the program and for program performers with regard to transition partners. That is, the transition of these capabilities to subsequent investment that may allow us to scale and refine these approaches for use in military contexts. A word about program schedule. As mentioned earlier, 3 sequential phases are envisioned, each with a point of evaluation at the end of the phase, as well as site visits and other interaction with both the government team partners and DARPA. And so each of these shows against the focus areas how the metrics step up in an orderly way to coordinate the work such that we can realistically expect to achieve levels of performance required to meet military specifications. So in focus area 1, as I mentioned, first, just produce 4 macronutrient classes from microbial cultures under the limitations we've imposed, learn to control those ratios, and ultimately aim specifically at the NSOR and NSRR standards within specified tolerances. With regard to tailorability, at first, just to demonstrate any flavor that meets or exceeds that like slightly or slightly like criterion. And we expect 1 food format, most likely a shake or a pudding. But through the program, we expect performers to acquire the ability to express more flavors and more textures in system output. And then finally, for focus area 3, first it is just assemble the essential processes on a benchtop and produce state-of-the-art, that is today's state-of-the-art, calories per gram biomass, show it's edible and in any volume, edible meaning non-toxic. The second phase will culminate by a test to show that performers are gaining on the ability to control the output, to improve caloric density, and to produce a total of 1 day of the required system output, but performers will have the opportunity to produce that 1 day's worth of output in 2 weeks of elapsed time with human intervention. And in phase 3, the idea is we put it all together. We're aiming at the higher level requirements, that is the operational ration standard. We're forcing that to occur in smaller amounts of biomass, so that increases caloric density. And the system must produce 1 day's output in 1 day elapsed time. In the broad area announcement, a detailed table of metrics is included. And for any of you who have interacted with DARPA before, you know you will have heard it said that DARPA is a metrics-based organization. I'm held to account for these metrics as the program manager, as are performers. I won't take the time to go through them in detail, but a general comment, I'll stress again that these metrics are derived from our own calculations regarding these use cases. And so the metrics are pegged to real life measurements, real life estimations. Of course, we expect performers will double check my work, but that's where these numbers came from. And again, they represent logical, ordered progression that achieves the levels of performance needed, as well as forces integration across focus areas and across use cases. While the two different use cases can be met in different ways, it's our hope that the program structure will allow performers to explore as many processes as possible that can be applied to both different use cases. In other words, that the program structure will reward solutions that where there's commonality or where a single solution benefits both use cases. You'll notice in particular that this is not an efficiency program, that the first phase includes no constraints on size, weight, and power to begin with. But by the end of the second phase, we're expecting performers to have estimated the envelopes of these use cases and to show that their system operates within twice that envelope. Likewise, for food safety, certainly the exclusion of foodborne organisms, foodborne pathogens is essential. But eventually, by the end of phase 3, the requirement is to demonstrate compliance with Department of Defense food safety standards. Again, these do not require human subjects testing. These are microbiological standards specified by standard regulation. So again, the two use cases not only drive our metrics, but they have been selected to bracket a much wider array of potential military applications. There's been strong interest from those interested in missions limited by food, for example, on both surface and subsurface vessels, both domestic and international humanitarian assistance and disaster relief operations, and many other applications where a backup source of food might be useful, or where food is limiting in terms of mission endurance or force readiness. So finally, a few key upcoming dates. So with that, I want to thank you for attending this Proposers Day. I want to express our excitement about the prospect of working with you to build out your proposals and develop winning proposals that are responsive to this call. And we certainly stand by with our GovTeam partners to assist you in every way we can. Again, thank you for attending and good luck.